Hi, everybody. I'm Ambarish Mitra, founder and CEO of Blippar. I'll just wait for my slides to kick in, and we'll start talking. But before the slides kick in, let me just quickly explain. For those of you who don't know, I like to, at this stage, presume most of you know what augmented reality means. Just for academic purposes, let me re-explain it to you. When a computer's camera looks at anything in the real world and gives you a layer of content on top of it, that's augmented reality. It's enhancement of reality. And often, a lot of the press and publication confuses AR and VR together. Again, for education purposes, VR is, you don't need to be in front of reality. It's like escaping from reality. You could be in this room and taking a trip in Venice or walking around Rome. It's completely not related to your immediate environment, so that's just for definition purposes. And of course, you're hearing a lot of the phrase also called mixed reality from companies like HoloLens and Magic Leap, where in future, when augmented reality and virtual reality could coincide and you could look at something in the real world and it gives you almost escaping from reality kind of content. But let me tell you a little more today about why this is really, really relevant. Before I dive into that, at Blippar, what we are trying to build is an augmented reality browser, or we call it ourselves visual browser. When you hear the phrase browser, you think of Chrome, Safari, and Internet Explorer, if any of you are still using it. You surf the digital world through URLs and through search engines. But just a reminder that the physical world is way bigger than the digital world. So you can literally look at anything and get to know more about it. That's what a visual browser would do. And it's very, very relevant because we do have a biological deficiency as humans. We have very limited vocabularies, and try it for yourself today. 70 to 80% things we see with our eyes, we cannot describe it accurately enough to find it. Very easy to describe things you want and search for it, but there are flowers and dogs and fashion items and monuments and products you see every day. If you need to know exactly more about it, you use stuff like barcode scanner, but remember, plants don't have barcode scanners. So there are millions of things you're seeing in the world which don't have barcode scanner, but you are curious. And also, secondly, like the very large sections of the population of the world can't read and write, and all of us are not very educated. So even the most educated person on the planet average is around between 10 to 20,000 word vocabulary. So this whole computer vision and AI will play a very big role in where the world is heading in level of information access. Let me give you a quick backdrop that how this is shaping up. And there's a very high correlation to how the human understands the world and how computers are evolving in general. So before computers became super smart, it was very keyboard entry based, and because it was taking from the legacy understanding of computers as desktop computing, where you could just type things on a keyboard. And when real AI started kicking in, one fundamental shift happened with platforms like iPhone. It's very human to touch. It's very intuitive behavior, and hence phone devices became touch sensitive. And then what happened is it's very human to talk and speak, and hence companies like Siri and Cortana, and now more dominantly Alexa, came into the mix. And lastly, what is happening now, it makes us massively human when we see the world. Mathematically, 83% of our learning, cognition, knowledge growing up comes from our eyes, and it uses like 40, 50% of our brain resources. It's equally hard in computing. So the complexity from moving from touch to sound to audio and then to vision, it's a very complex curve, but that's why this is a problem that is being handled. One of the last and imagine trying to mimic the human eye and trying to understand the world literally, how much of an effort computers would take and how much data would be required. But it is critical to do that for augmented reality to scale. And I'll explain that in the next slide as we move forward. So this is a typical screen how a computer sees the world. In those technical among you, this is called a classifier. You know, when we run this picture through a program, it literally explains to you semantically what it is looking at. And what this picture doesn't depict yet, that it is literally in isolation saying a man and a boy and a running and a dog. You know, it doesn't explain that a family is having fun, and we're getting there, but it's right now semantically just literally giving you an isolated understanding. But it's very important to know that whenever you think of augmented reality, from many of you in your minds, the images of dinosaurs coming out of screens and very funky games happening, that's all cool, but you got to remember that this is going to be a very serious technology which is going to redefine how humans access everyday information. But this is our personal prediction that for augmented reality to scale, computers really need to understand reality really well. So you are hearing a lot of announcements from Facebook, from Apple, talking about AR Kit, which is more focused on the geometric side of computer vision. And I'm going a little academic here, but this is useful information for you. When a computer sees the world and it understands depth, location, the geometry of the visual space, a lot of that is being done by HoloLens, ARKit, Tango. The area we are focusing on as a company, Blippar, is the semantic side of computer vision. We believe that if computers can understand, hey, that's a table, it's a wooden table, that's a plant, that's an exact dog, and literally everything in the world, we can give people the provision to add amazing amount of entertaining or utilitarian content on top of it. So these are two different fields, but no one's actually managed to build a system yet which covers the both semantic and the geographic side, geometric side really well, but it's getting there. These are just some examples of how AR is already defining information access. So just on a very basic level, you can look at most products and get to know more about it. Not just more about it, you get to know how that product is connected to everything else in its immediate universe. Google calls this knowledge graph, and what you're seeing in the screen is like a visual interpretation of that knowledge graph. It'll also help us how we shop. So you look at something, you can virtually try on. A big industry that is already taking shape in the AR space is makeup. You know, how precision makeup looks on a woman's face or a man's face, or nail varnish on your hands. Very precisely, it creates an impulsive shopping experience into a persuasive decision making, and you end up buying those goods. And so far, a lot of the campaigns we've done, we're seeing like very high engagement numbers, very high dwell time. But we've seen this in the past where things have been done with QR code, but what QR code doesn't do, it doesn't create an emotional response. It's very transactional. So hence, conversions would be pretty low. But if you can just check something out and it gives you a very visually rich experience, the conversions are really, really high. Another large area AR is already beginning to impact is education. And remember that quality of education is not defined by how the top 50 percentile of a class is doing. It's defined by actually how bottom 50% of the class is doing, because that's where real impact and real change is required. And we are seeing already with augmented reality that students' attention to complex lessons, whether it's understanding of physics, it's understanding of geometry, through really visual mediums, the results have been astounding, and even initial results show that weaker students remember a lesson plan 6 weeks after first engaging with it. And there are a lot of schools are today, like around 35,000 schools around the world, are working with us with really interesting ways to engage younger kids, and we feel AR will play a very big role in that. And lastly, everything else. I mean, you've already heard of companies like or games like Pokemon Go, which was like a worldwide sensation last year. But that was literally a trailer. The mechanics of the game was impressive, but visually it could be a lot more. And you will see now, particularly from later half of this summer, that incredibly more cooler, visually rich games, incredibly more social movements. So far, you've seen with things like face filters on Snapchat, which is a very rudimentary example of how AR is being applied on a face level, but that's just like a tracking mechanism on the face. But you will see this playing a lot deeper role in the society and the future of social networks, and how you will walk into environments, and literally your face could be used for socializing, for payments, for networking. The list carries on. So we will see like a whole different way how you discover the world around you. But I always struggle with explaining the AR phenomena with words, because I deeply believe words are not enough. So why don't I give you guys a variety of demonstrations, and just to give you sort of a trailer of where the world is heading towards, and I hope you enjoy it, and hope the internet doesn't betray us either. So if we going to move to demo screen, so you can see my phone. And also, I'd like to apologize in advance that for some reason, last 2 hours, my phone's volume went out of control, in the sense that it's gone mute, so you won't be able to enjoy the audio experiences of it. So what you're noticing here, I just launched the Blippar app, and what's being demonstrated is the world's first, and right now only, AI engine, which is understanding what it's seeing in real time, like a real human being. And all the words, if you try and read into it, it's saying whatever it sees. And its level of accuracy is only as much what the computer camera can see. And the reason it came out nightclub with the purple light and all these things, it really thinks it's we're in a nightclub. So, and of course, the way you guys are behaving as well. So it's making me look like a rock star. So yeah, it says bright light, performance, nightclub, dancing, crowd. You know, you're starting waving. So it is reading, and it's a brain of like a 10 to 12-year-old kid. It's trying to explain everything that's going on a generic level. Now, and it'll change. It'll change to the environment will change to whatever you digital clock. Yeah. It's a computer. It's getting there. You saw the digital clock beside the mouse trap. So it recognizes today 70 to 80% of most things in the world, and it gives you content. But also, it can go down to really specific things. So let me demonstrate it with a car. I couldn't bring a real car here. So immediately it gets it as an Audi 2017 model you saw, Audi R8. When I click on it, this is what is called a knowledge graph. All this content is AI generated. So you'll see, hey, look inside Audi R8. So there's a content partnership we've done. Should load in a second. So now the very car we just blipped, this is like a semi-VR. I call it semi-VR. It could be richer. I literally need to walk around to check it out, check the interiors out, check the roof, how it all looks like. I can reset, exit vehicle, and then I come out of it. And then I can say I want to discover more. There's a lot of trivia content and indicative pricing. But this is almost like the DNA molecule of this car. Now from Audi R8, if I'm interested in Audi, the car manufacturer more in detail, it'll take me to everything about that vehicle. That group vehicle. And now it says more about the company, the Volkswagen Group, the founders, and automotive industry. So you can move from one random object, which is parked in the street, to something else, and you can browse for the rest of your life, and you will not come to an end. There are 5 billion facts and 43 million entities of content on this system already today. So you can try it on cars today. That's just one example of generic stuff. Now, if I move to another category, which is really picking up, is faces. So these are just magazines I bought. So I'm going to try putting it. It's quite fast, so it'll respond very quickly. So it recognized Kate Middleton immediately. Now, if I go to any other parts, and I want to explain to you that this is not image recognition. This is actually deep learning. So it will recognize Kate Middleton in person. It'll recognize her on TV. It'll recognize her on magazine, or it'll recognize her anywhere, for that matter. And I'm just thinking, who else can I show you here? I'm thinking of a totally unknown face. So here is an ad of L'Oreal. Here's an ad of L'Oreal on my phone. Just ignore one sec. So we don't know who this model is. And now we get to know that it's someone called Leah Kebede. Literally from a random magazine you can pick out. And I also brought, just to show you this is not image recognition, today's Financial Times. Just picked it up from the speaker's room. And on the cover is the new French president. Again, you can see his one eye is closed, his half of his face is there. This is, today we have a database of 370,000 public figures, and it can recognize all of them. So cars, landmarks, people. Now what happens when you engage with a commercial content? This is an ad with Procter & Gamble with a campaign call. It also recognized the model while it was looking at an ad. It tells you more about the product. You can watch tutorials. You can create videos, things like that. If I point it at, I don't know, like a famous painting here, you will notice something else. There's a very famous painting by someone called Scarlett Raven, who's been appreciated by the Queen recently. Again, you see what she's doing. She's making half the painting in the physical space and half the painting in digital space. Literally just by pointing your phone, what was pointing at people's faces a moment ago. Now this is another guy, he's a very famous Formula One superstar called Max Chilton. He's doing some creative stuff on the platform. Again, this had amazing music. Sorry, I can't show it to you because my music's not working. But I want to show you some cool feature. I'm holding a piece of paper, and there's a three-dimensional Formula One car driving on that paper. If I tilt the paper left, the car moves left. If I tilt the paper right, the car moves right. So though the paper is at all not connected to the phone, it's an independent entity, it just shows all the laws of physics are also being applied in AR, and you can be a lot more creative. So everything I demonstrated to you guys today, whether it's a face or automotive or general objects, it's available as an API, and we are encouraging developers to come and build incredible stuff on the platform. Thank you very much.